Okay, I'm going to go ahead and share my screen. Because nice to meet all you guys who've been in this virtual setting. Very happy to be here today about some of the work I've been doing with digital audio glitches, primarily in chucK. My institutional affiliation is different from what's on the proceedings. I was in the States for a while, back in Canada, where I'm from originally, but that's not the most important thing in the world. So this Luka-chucK environment, this is kind of either the first version or pretty the first version. So any thoughts that you might have on improvements, suggestions, criticisms, feel free to share, or you can contact me via email afterwards. So, why am I doing work with Glitch? For the most part, I work with electronic computer music has been with computer music languages, stuff like chucK, RPC, Next, Super Collider, and I found that in learning these, especially learning these, dealing with programming from a music background, malfunction was just kind of a natural part of the learning experience. And oftentimes I found myself holding on to things and discovering happy accidents. So there's that aspect. I also think that Glitch is very interesting in the way that it responds to issues of commodification of production. It kind of offers a more sharing, community-based approach that is, allows the practitioner to kind of create more unity within the compositional process and the technology, in that the way that you pursue malfunction will have some kind of reflection on the compositional output. So my first kind of good piece that I did, where I was using a lot of these happy accident glitch sounds that I was finding, is called My Metal Bird Can Sing. It was in 2015. I thought I'd just play a short excerpt of it to get a sense of the kind of sound world that I'm talking about. Are you able to hear that?
Yes.
Yes? Okay. I found that juxtaposing the kind of glitch sounds that I was getting out of chucK with some of the other elements in the kind of fixed media piece, like MIDI instruments or even software synths using oscillators, it was kind of difficult to deal with the inherent unpredictability or indeterminacy of the glitch sound and the relatively controlled nature of something like pitch and rhythmic elements from a MIDI instrument in something like Logic Pro. So I started thinking about codifying, collecting, and trying to kind of filter a lot of these results I was getting in chucK into just instruments that could be reused and understood to a certain extent. And aside from reconciling the glitch and non-glitch sounds from a technical perspective, I also felt it was important to kind of explore how these sounds resulting from malfunction could be used for kind of expressing things other than kind of the harsh or aggressive kind of side of music. I think glitch is often kind of placed in its historical trajectory from Luigi Russolo and Stravinsky, emancipating dissonance and noise, and later on, eventually, we get this kind of whole genre of kind of loud, noise-based malfunction music. But I think that's a kind of incomplete way of thinking about glitch. So getting into the actual environment, pretty much the whole thing exists in chucK, and right now the current version is best used just manipulating the chucK code. There is the maximum speed interface, but it's a little bit buggy to be totally honest, and it's kind of, I think, it's more of like an optional element of the entire environment. So the way that it works is that I have these 8 instruments, these 8 kind of glitch instruments that all have controllable parameters. So on the bottom right, next to each sport, there are functions which call kind of programs that play the instruments. Each of the instruments is embedded in this chucK-graph class, which is a very useful feature in chucK, where you are able to create new like UGens or kind of pseudo UGens. So these are kind of computer music instruments themselves. They don't introduce anything new to in terms of synthesis or processing, but they can be used to kind of repurpose existing UGens in the chucK language. This is especially useful as I'm not coming from a computer science or engineering background, purely a musical one. So not having to delve into the deep down C++ stuff was very nice, and kind of helps speed along a lot of the aspects of this project. I also chose to work in chucK specifically because it has this like really, really specific and structured way of dealing with time using the now keyword, where you can just say, okay, let's do something for a while, specified by how much time I'm passing to now, and then we'll do the next thing based on how much time is passed to now. So this is very nice to have this very tightly controlled time, because glitch sounds often don't react in the intended way in terms of how sounds are dispersed over time, how, like in terms of a rhythmic or meter way, how things are working. One of the big features that I'm working on with this environment is also creating kind of interdependency between instruments so that they become less just kind of an ensemble and more of an environment. In the paper, I mentioned this mapping function that I have here on the left. That turned out to be way too fancy and not especially practical, and I found a much simpler way of just using global variables. I don't know how familiar people are with chucK or computer music programming, but if you look when I put this on my site this upcoming week, it's way less work to get an interdependency between the instruments, just using simple, like this play cloud and the play folds can each share information using just a simple variable like this float, rather than doing all sorts of stuff here like I have on the left. So the way that I use the environment now, all of the instruments of the ensemble are added using this machine add command so that they can be used as public classes all over chucK in different chucK files. There are scripts where you kind of input what you want the instruments to do. And then there's a main hub where you have things like ADSRs and LFOs and the OSC routing between chucK and maps. So more on the basic structure. Each one, because they all respond to, they all kind of deal with things like frequency and general pitch level in a different way. I thought it was important to input this shifts function, where I'm just controlling using pitch shifting and LISA, which is the live sampling utility in chucK. It's just a way of imposing across the board some general control of pitch level. And this just shows the way things are flowing in the kind of main class that I mentioned, that Luka-chucK class, where we have chucK-graph instruments, they flow through LFOs and ADSRs to the DAC. So, getting into some actual sound and how things are working. So the first member of this glitch instrument ensemble I called Resin Glitch. It was the first one that I discovered. And I think I ruined everyone's day at the coffee shop I was working at when I first discovered this one. If you can see how low the gain is in this image on the top left, originally it wasn't that low, and some not so nice sounds happened. So the way this one works, it's mainly taking a resonant bandpass filter in chucK and feeding it bad input to the quality factor, the Q. The Q should be more than 1. It should be in a range of at least 1 and probably something between 1 and 100. But I'm giving it a float that is less than 1. And what you get is this sound. And so I kind of controlling time using the dot freak, like the frequency of the sound fed into the filter. So I found that it was completely unpredictable. So the only way that I could control time with this instrument is using the frequency here of this OSC hertz. That controls basically how long each swell in the sound will be in terms of hertz instead of seconds. Okay, other things. So, whoops. So this instrument uses Boltover from aliasing, so from going well over the Nyquist frequency. But there's already a lot of instruments out there that do similar things. So one thing that I focused on is trying to give predictable input so that the fold-over frequencies can be controlled. This is pretty similar to what's happening in a great paper by James Dashow about creating chordal structures using fold-over and FM. So for example, I can specify I want a C diminished seventh triad or a G major triad as the input to the fold-over instrument. So I can also specify with this particular one MIDI note and frequency, but I felt that the chordal approach was particularly interesting. So I could create just kind of functional harmonic progressions using these glitch sounds. Next. So this one is based on the sound of the click, the little artifact you get from instantaneous changes in things like amplitude or the frequency of the filter. And it takes those clicks and harmonizes them using comb filters. So that's where you get those kind of bright, kind of nice, shiny frequencies. Moving on, I'm a huge fan of using the physical model from the STK in whichever languages that they exist in. So in addition to kind of trying to tune them to make them sound more authentic, I decided with this environment to go in the complete opposite direction and say, there are a lot of interesting things happening to make an instrument. You need a lot of filters, and there are a lot of delays. There's a lot of kind of useful stuff under the hood that can be plundered. So what happens when I start, giving bad input or trying to sweep the arguments past the maxes using things like LFOs? So some examples. This one uses the mandolin Eugen and feeds really low input to the body size and to the frequency. So when below 20 hertz, the body size is like 0.001, stuff like that. And what you get is you get to take hold of some of the delays inside of the Eugen, cause them to malfunction. Another example. Is taking the banded waveguide unit generator, and this one is it's repurposing the bowing position and the pluck. So I don't know if it's a conflict of interest to kind of mistreat these instruments that people spend so much time trying to develop. But I think that, it's in the spirit of plunder and discovery, and it's helping me get new material for pieces, so I'm overall not too concerned about it. So a couple more examples. This one creates kind of changes in panning that are occurring less than 100 millisecond range to create more kind of signal discontinuities. And this one also is based on fold over. So it kind of does the opposite of what a band limited oscillator should do by giving it way too many harmonics. So somewhere over 48 kilohertz in terms of the number of harmonics to create interesting fold over frequencies. In terms of Maximus P, I think this is where it's become more of an environment. It becomes easier to route parameters. So for example, I can using these like new menu objects, pair different parameters belonging to different numbers of the ensemble. So like the pitch level of the not waveguide can be synced to a parameter of the non-mando instrument. I have a little bit of trouble thinking of how to define this set of tools, if it's like a meta instrument, is it an environment? But I think the more I start to integrate features in Maximus P that help or the interdependency between the different subgraphs, the more it'll become an environment for composition. And I'm also thinking about like how I can rethink things like ADSR sequencers so that they're not dealing with only things like velocity or the transposition of many no values and sequencing instead parameters like comb filter frequencies and certain like brain durations. So the Maximus P interface is the place where there's the most work to be done by far. But there are other things such as for the fold over and where I can assign chords, thinking about going beyond pitch structures in Western art music and how I could maybe introduce some kind of scales or modality from outside of classical music. I think that would be an interesting addition to the environment. So, I don't know how short or long that was, but that is where I'm at with the environment for now. And I know that was all very chuck specific. So, sorry if it was all chucky nonsense, but I'm happy to answer any questions anyone has.
Does anyone present have any questions? I like the sounds, they're very beautiful. I don't really have a question, but I think I can see how interesting it might be to feed these physical models, as you said, that are so carefully hand-tuned to do something quote-unquote beautiful, and then you feed them these very extreme parameters to get them to behave in such a way that they were not intended. So, and that part of it is actually quite beautiful to me. So,
Thank you.
I do have one maybe little question, because I wasn't quite sure. You said this idea of glitch as kind of noise in the sense of like loud sort of improvised noise concerts and stuff was very limited. Does that mean that you're going for a kind of use of noise in a different, or maybe different musical context?
Yeah, like I think that malfunction and sounds that emerge from malfunction don't have to be so genre specific. And this is right, or kind of like, this is a good area of exploration for seeing, you know, how sounds emerging from malfunction create something more ambient instead of maybe like aggressive or cacophonous.
Because of course there's already kind of a whole world that does that, you know. So, but I'm interested to hear what you come up with. The sounds themselves are very beautiful. I wonder what they would sound like in a piece. I hope to hear some of your music. So.
Thank you.
Do any of our virtual participants have any questions or comments? No? Then that puts us like literally exactly on schedule for our very next